Hi everyone. Today we're going to continue adding and subtracting rational expressions. This time though our denominators are not going to be the same. So we're going to have to do a little extra work to get them to be the same before we can combine them like we did yesterday. So just like yesterday, I wanted to practice with a fraction before we applied this to rational expressions. So if we look at our original expression here, 1/4 plus 5/6. 4 and 6 are not the same number, so we had to find a common denominator for those. Now in the blue box, I did the work for finding that common denominator. 4 is the same as 2 times 2. 6 is the same as 2 times 3. Now in order to be the LCD, it has to have all of the factors from both of those numbers. For example, 6 is 2 times 3, so 2 and 3 have to appear in the LCD. Now 4 consists of 2 2's. So we need to have 2 of the 2's in the LCD. That's why it's 2 times 2 times 3. Now if we multiply those three numbers together, we get 12. So our LCD is 12. So when we go to find that LCD or to create an LCD for these, we're going to multiply by the missing factor. So the 4 has 2 times 2. It's missing the 3 of the LCD. So I'm going to multiply by 3 times 3. For 5, 6, the 6 has the 2 and a 3. It's missing one of the 2's of the LCD. So we're going to multiply by 2 over 2. Then if we look at the next line there, 3 times 1 is 3. 3 times 4 is 12. So we have 3 twelfths. 5 times 2 is 10. 6 times 2 is 12. So we have 10 twelfths. Now our denominators are the same, and we can work through the problem like we did yesterday. We'll combine the numerators to make it 3 plus 10 over 12. 3 plus 10 can be combined to make 13, and so we end up with 13 over 12. And we want to leave it as an improper fraction. You don't have to worry about changing it into a mixed number for something like this. So just like yesterday, we're going to follow those same steps. Now yesterday we didn't really have to deal with finding steps 1 or 2 because we already had the denominator. That's not the case today. Now we're going to have to find that least common denominator, step 1. And then in step 2, we are to multiply each fraction, so our rational expression, by any factor missing from the LCD. Then, just like yesterday, we're going to go to step 3 and add or subtract the numerators. Now, if it's subtraction, remember that subtraction sign has to be distributed through the entire numerator. So whatever's after that minus sign, you have to put in there. Step 4, you're going to simplify the numerator by combining like terms. So if there's x's in common, combine them, numbers, constants, combine those two. Step 5, you're going to go about simplifying it. You want to check to see if the numerator can be factored or if anything can be simplified. So let's try a few of these examples that involve variables or rational expressions. Now if we look here, our first fraction is x minus 4 in the denominator. The second has x plus 5. So our LCD has to contain both. It's going to be x minus 4 times the quantity x plus 5. Okay. So the first rational expression, x over x minus 4, it's missing x plus 5. So I'm going to multiply by x plus 5 over x plus 5. The second fraction, or rational expression, is 3 over x plus 5. It has the x plus 5. It's missing the x minus 4. So I'm going to multiply by x minus 4 over x minus 4. And I'm going to put parentheses around this. It makes it a little bit easier. So that x is going to be multiplied by both the x and the 5 there. So x times x squared. 5 times x is 5x. So I have x squared plus 5x. I'll go ahead just to save some space here, write as one fraction. Quantity x plus 5 times the quantity x minus 4. And we have our plus sign. And that 3 is now going to be multiplied by this x and this minus 4. So 3 times x is 3x. 3 times negative 4 is minus 12. So now we can go about combining our like terms. There's only an x squared here, so I'm going to leave that as is. 5x plus 3x is 8x. And then I have that minus 12. That's going to be all over x plus 5 times the quantity x minus 4. Now at this point it doesn't look like it'd be simplified, but we could probably go ahead and we could factor that numerator. So we need two numbers that multiply to give us negative 12 that add to give us 8x. And to be honest, I don't think there's any numbers that will do that. So this would be our actual final answer. So x squared plus 8x minus 12 over x plus 5, x minus 4. But you always want to check to see if it can be factored. Now we also talked about restrictions. Just a reminder, x can't equal negative 5 or 4, because either of those numbers would make the denominator equal to 0. Okay. Look at our next example. Before we can even start, it's a good idea to go ahead and factor that x squared plus 3x minus 10. Now if you were to factor it, it's going to be x plus 5 times x minus 2. And that's actually also going to be our LCD. Notice the other fraction has the x plus 5, which is already part of this LCD. And so that first fraction, 3x over x squared plus 3x minus 10, I don't need to multiply it by anything. It already has both parts of the LCD. But the second rational expression, the 2 over x plus 5, it's missing the x minus 2. So I'm going to multiply by x minus 2 over x minus 2. So if we look at our next line, we have that 3x. I'm going to write this as one big fraction here. The x squared plus 3x minus 10, I'm going to write this in factored form. X plus 5 times the quantity x minus 2. And then I have this minus 2, and that's going to get multiplied by the quantity x minus 2. So I do need to distribute that through the parentheses here. So that 2 will get multiplied by x, and that minus 2 gets multiplied by negative 2. So when I do that, of 3x minus 2x plus 4. And that's all over x plus 5 times the quantity x minus 2. Now 3x minus 2x is x. So I have x plus 4 over the quantities x plus 5, x minus 2. And there's nothing else that could be simplified here. Now I do have to think about restrictions. So we look at that denominator, and we don't want the denominator to equal 0. So we have to look at what values could possibly make the denominator 0. And that would be negative 5 and positive 2. There's our final answer, and these are our restrictions. Okay. Last one has 3 terms. Now if you look at that last fraction here, x squared minus 1, 6 over x squared minus 1. X squared minus 1 is the difference of squares. So that could be rewritten as x plus 1 times the quantity x minus 1. And if we look at the first 2 fractions, they have those as their denominator. The first one is x plus 1. So if I was multiplying it by something, to get that common LCD, I would do x minus 1 over x minus 1. The middle one here, the 3x over x minus 1, it has the x minus 1. It's missing x plus 1, so I'm going to squeeze that in here. It's going to get multiplied by x plus 1 over x plus 1. just add some parentheses in there. So my common denominator would be x plus 1 times the quantity x minus 1. So I'll have 2x times the quantity x minus 1 minus 3x times the quantity x plus 1 plus 6. And that's all over x minus 1, x plus 1. So now we need to simplify that numerator. So I'm going to have to multiply each of these terms with 2x times x minus 1. I'm going to have the 3x minus 3x times x times that one there. So let's start here. We'll have 2x times x is 2x squared. 2x times negative 1 is minus 2x. Then we have our negative 3x times x, that's minus 3x squared. Negative 3x plus 1 is minus 3x. And then we have that plus 6. And that's all over x minus 1 times quantity x plus 1. Now that numerator can be simplified. We can combine like terms. 2x squared minus 3x squared is negative x squared. Negative 2x minus 3x is minus 5x. And then we have plus 6. And that's still over x minus 1, x plus 1. I'm going to bring this up here. Now, we could factor that numerator, but before I do that, I want to take out a negative. Because it's a lot easier to factor when it's a positive number in front of x squared. Now, taking out a negative is going to change all of those signs. And that's all over my x minus 1, x plus 1. Now, the numerator is going to factor into being x plus 6 times the quantity x minus 1. That's still all over our x minus 1 times the quantity x plus 1. Now we can simplify this one. Since they both have an x minus 1 in common, I can factor that x minus 1 out of the numerator and denominator. That leaves me with the quantity negative times the quantity x plus 6 over x plus 1. And the x plus 1 you can put in parentheses or not. It's your choice. I'll go ahead and put the parentheses in there. So that's our final answer. Now when we look for restrictions, we want to make sure that we look at that original denominator. So x cannot equal 1 or negative 1. So that concludes our notes for today. If you have any questions or comments, go ahead and leave it in the comments below, or you can leave me a note on Google Classroom, or you could send me an email. I'll talk to you later. Thanks. Bye.